Okay, as you're finishing up, here's some things that you know from junior high and other classes. Product, when you're multiplying, when you multiply with the same base, the exponents get added. Okay, so this is stuff that you'll be familiar with as we start using it. Power to a power, they get multiplied. Okay, negative we talked about yesterday, went on bottom. Zero's a fun one, we'll do that one again. Division, same base, the exponents get subtracted. Okay.
So, can you send Paul Johnson to the office after class?
Yes.
Thank you, ma'am.
We're also going to look at using these rules when there's a radical involved, like a square root or a cube root or something. That's when we're going to have to remember how to break down stuff that we did earlier in the year. How we do it? I know you're still writing because you're quiet. We're getting close though. Yara?
Yeah, my hand's just like not working anymore.
That's your problem. Okay, that's okay.
That was so rude.
That's me.
I said I'll retry it today. She goes, that's something new. It's fine. Sorry, I'm so stressed.
Chloe, you usually do a lot.
Look, you're not. I don't know. But now she goes that way because of the
How much more would you like?
I'll just look at it.
Well, you still have to be writing it down, though. I don't want you to get behind while you're writing it down.
He has 3 examples.
Man, I can't.
That's my kind of question. I never even had an answer. Are you okay?
I got 4.
Okay. You are? That's awesome. You know what? That's tips. That's awesome. I don't know about that. How many strings does the violin have? That's what I was thinking. Maybe, but I was thinking 4. Okay, so you got good. Okay.
There's 4 strings. Yeah.
Is the thought that you play chords like other stringing instruments? Is that?
It's like, it's more like a ukulele.
Yeah.
It has like the same amount of chords.
Alright, please turn the light on. Everybody got their eyes ready?
You gotta make this stuff interesting.
I warned you, honey. What are you blowing about?
I hear you.
I can see what I'm doing in the dark.
To the heating warning.
At least the blinds.
I can hear it. So warning.
Why do you think I went like this?
It's small.
We have our straight lines. Mine are not very straight.
Okay. So you've got those properties fresh there where you can see them. So this first problem that I have here says 5 to the 2/3 times 5 to the 4/3. So you're getting these in your notes here. We're going to walk through some properties and work through some stuff together. So what I notice on this one, this would be like your product property, because I got the same base and I'm multiplying. So on your product property, it said that the A carries over. So here my 5 is going to carry over. And then just like Mr. Cross said, I'm going to add those exponents. Now this one's friendly for you because those fraction exponents both have a common denominator. So you can just do 2 plus 4, which makes 6/3. And what's 6/3 the same as?
2.
2. So now all you got to figure out is what is 5 squared?
25.
25. Y'all are rocking and rolling. Alright, here I got 3 to the 1/5
Is it the same?
times 3 to the 4/5. So I'm going to give you a second to try that one on your own. It's just like the one we did above it.
Is that 4/5?
Would answer be 3?
Well, I didn't hear you,
The
buddy.
answer would be 3.
Very good.
It's fine.
Okay, what am I going to do with those exponents?
Adam.
Add them. 1/5 plus 4/5 gets me 5/5. What's 5/5 the same as?
1.
What's 3 to the first?
3.
3. Now, let me caution you on some things. Could I, oops, I'm going to pick a highlighter. Could I have just done this part in the calculator and got that? Yes, I could have. Okay, but here's why I'm not. Because in a little bit, we're going to have variables here. And so we got to know how to simplify the exponents then, because you can't put a variable like that in your calculator. It doesn't do the work for you that way. So we still got to know the rules. All right, let's change gears here. I got 4 to the 2/3 to the 3rd. Okay, so this is a different property. Should look different to you. This one's the one, I don't remember what the note said that you wrote, but this is the one I call power to a power. Because you got a power in the parentheses and then you got another power outside.
Would it be equal to 4 6/3?
Okay, what do we do on power to a power with those exponents? Okay, so we got 2/3 times 3, which Garrett is correct, would be 6/3.
Which would equal 2?
6/3 is the same as 2. No? 16, very good. That's a common mistake. Okay. Product property, the first two were product properties. Alright, let me give you one of those to try real quick. This one says 10 to the 1/2 to the 4th. So that's just like the one above it that we just did together. Give that one a whirl, see if you can get it figured out.
Be 10 and 4.
Alright, so what is it I'm supposed to do with those exponents on this one? Multiply them, so I got to figure out what 1/2 times 4 is.
10
Very good, Michaela, skip me a step, I like that. Some people would still write 4 over 2 here, so she sped us up. What's 10 squared? 100. No. We're getting there.
What a prank.
Everybody good on this? I'm going to let Riley get caught up and we'll switch pages and switch gears. Alright, let's look here. I got, oh, my bad, hold on. It's the one power to power. Yep, that's the same thing. It's like power to power. The second is the quotient of the power. Alright, let's look at 8 to the 5/2 divided by 8 to the 1/2. Alright, so I've got you a new page. We switch gears. What's going on? What is that? 8 over 8. What kind of operation is that? Division. So on your sheet, that's quotient. Okay? So we got 8 and 8. So just like on our sheet where they carried the A over, we're going to carry the 8. Then what do we do with those exponents on division? No? Subtract. Multiplying Multiplying, you add your exponents, so division is just the opposite. You subtract your exponents.
Would it be 4 over 2?
Okay, so that gets me 8 to the 4 over 2, which is 8 to the 2, which I'm finally caught up with Chloe, is 64. Alright, this one says 7 to the 2/3 divided by 7 to the 5/3. And I'm going to let you try this one.
Will that be a negative?
But this one is going to involve a negative, which is a new property on your sheet. So see what you can come up with. Then after this, we'll move on to roots, radicals. We're doing good. In the morning. 7 to the 5/3. And what do you do when you get a negative exponent?
You have to put it over 1.
Put it under 1, yeah.
Because it's your positive. Because the next one always has your positive. Because you can't have negative.
Great. So remember the stuff. What you know about that?
You can't have that like you don't have negative.
So you just put it in.
You put it under 1.
Take the reciprocal of it.
Then it becomes
No.
Oh, I meant wait, no, I did it wrong.
maybe an X
Do
7.
you need me?
I put 8 instead of 7.
Hey, it's 7
I know it's 7, but like, I was starting to put 8.
Would it be 1 over 6?
You're close.
Is it 1 over 7?
This
This is
Well, you put 1 over 7 negative 1, so I thought it'd be
When you put it on bottom, it turns that negative into a positive.
8.
I do.
No, that's an exponent. 7 to the first is 7.
Oh.
Okay, let me get caught up with y'all. This is just like, you ready, Marshall? This is just like the previous problem. It's division. So we're going to subtract those exponents. And you saw here that if you take 5/3 away from 2/3, you get a negative. So that was 7 to the negative 3/3. And negative 3/3 is the same as negative 1. Okay, but now this grabs another property. The 0 exponent, wrong. The negative exponent property. Okay, can't leave a negative power like Grant was saying. So when we have a negative exponent, our rule says we take the reciprocal. We put it on bottom and make it positive. So what is 7 to the first? Well, it's just 7. It'll be fine over there.
Wait, so the semester test is going to be all we learned?
I really hope I don't take that because it's not going to help me. It's just going to make my grade go down.
Wait, so what if we don't have to take it? We take it.
If it helps you, it will help you, but I won't make it hurt you.
Now,
I cannot miss any more days. I can't
All right, let's check this out.
dying over here.
All right, so we've got square root of 3, listen, square root of 3 times the square root of 12. Now, we didn't have a list of properties to write down about radicals, so we're just going to do some examples and look at some things as we go. When your root index is the same, you can just do the operation underneath it says. So what I'm talking about, this is a square root and this is a square root, so it's the same. If I'd had a square root and a cube root, wouldn't be the same, I couldn't do anything. Okay? But since they're both the same, we would just leave it. Since they're both the same, square root times square root, my answer will be a square root. And then since this is multiply, I do my multiplication, 3 times 12. Now if we can break it down, we do. This one's nice and friendly for you because we know the square root of 36. Positive and negative 6. Very good, Angel. Okay. Wonder about a cube root of 5 times a cube root of 25. So my first question to you is, can I do anything to this? Yeah, they're both cube roots. Very good. Y'all are so smart. That's why y'all are my favorites. So my answer will be a cube root. Now, what is 5 times 25? 125. Thank you, ma'am.
And then you do cube root up.
Okay, so first thing I'm going to do, if I don't know, but that's a pretty common one, a lot of you will know it. First thing I'm going to do is check and see if it is a perfect cube. So if you hit math and go down to number 4 in your calculator, it's got a cube root there for you. Remember, if it's bigger than a cube root, you have to do it a little bit different way. We talked about it yesterday, but check and see. What did you say, sweetie? 5. When it's an odd root, 3 is an odd number. Do I put a plus minus? No. Very good. Look at y'all.
I
Knowing
decide
stuff.
before I get
All right, let me let you try a 4th root on your own. 4th root of 27 times the 4th root of 3. See if y'all can figure that one out.
Would it be plus or minus since the 4 is?
Yes, even number plus minus. Good job.
I'm so smart.
Y'all are smart. Sign y'all up for
I forget how to do it for math test, but at least I feel good.
the has to be a mathematics.
These are too easy.
I've never gotten to that. I think you have to know like other stuff too, not just this.
No,
Just one part of
figure
it.
it out.
I have to make a button C on the income test, so I'm gonna go with. Oh yeah, next semester I'm getting 100 every
The square is 4. So that's why you leave it plus or minus because it's even. If it's even, there's plus or minus. If it's odd, then it's not. 3.
Here, you get plus or minus.
No, but yes, plus or minus because it is even.
Very good. Alright, so you had 2 4th roots. So you had 2 4th roots, so you kept a 4th root. Shh. What was 27 times 3? 81. Then you had to check and see if 81 was a perfect 4th or not. Was it? What was it? 3. And since my 4 is an even number, I give my plus minus. Shazam! Okay.
I think we're done.
No, we got a couple more, a few more, but we're getting close. We are going to have to eventually look at, remind ourselves what to do when it's not a perfect. You know, when we got to break it down, somebody comes out to play wiffle ball, and somebody stays in the house to do chores. Yeah.
I think that's on our test. You just make it all. I don't think that should exist.
Yeah, it does. Okay. Those were all multiply, so let's divide. Great idea, thanks. Square root of 98 divided by the square root of 2. Alright, so our rule here for the division is the same as it was for the multiplication. If it's the same index, the same root, you can divide it. So these are both square roots, so you're good to go. Keep a square root in your answer and figure out what 98 divided by 2 is. 49. Okay, now is 49 a perfect square? 7, Chloe. Is it positive, negative, or just 7? Very good, G-Dub and Kason.
Calm square body. Calm square body. Square body truck.
Okay, this one's a little different. Still a division, so I got the 4th root of 4 divided by the 4th root of 1,024.
Oh, wow.
Let's see.
Okay, so they're both fourth roots. Y'all listening? They're both fourth roots, so you can divide them. So does 4 over 1,024? That's obviously not going to go evenly, but does it reduce to what?
It would be 1 over 266.
Okay, so I've got
Square root,
the
right?
fourth root of 1 over the fourth root of 256. All they did to get that was divided them both by 4. Okay? Alright, now is on the top, is 1 a perfect fourth? What's the fourth root of 1? What times itself 4 times equals 1?
1.
1.
Oh, balls.
On the bottom, what's the fourth root of 256? What times itself 4 times equals...
64?
No. 64 to 64 to 64 to 64, no.
Oh, no.
Do it on your calculator if you don't know. 4, very good, Michaela. Speedy Gonzalez. Does my 1/4 need a plus minus? Yes. Yes, yes, yes. We all right?
Yes.
Yes. Good. All right. This next one is one of the everybody's favorite kind. Not really, but we're gonna do it.
What reminds you of
I've got the square root of 27 times the square root of 6. So this looks like the ones that we previously did. Starts off the same. We got a square root and a square root. So our answer is going to be a square root. And then we just multiply 27 times 6. So what do you get? What's 27 times 6?
162.
162? Alright, so I got the square root of 162, and I'm looking over there on the list that 6th period made by Hunter, and I go from 144 to 169. So there is not a 162. So this is one of those that Maddie was asking about earlier. Are they always going to be whole numbers? No. But we're going to put the exact answer. We don't get to put the approximately like we did yesterday. We got to find the exact answer. So I'm looking over there on the list by Hunter, and I'm looking for something smaller that will go evenly into 162.
4 will.
I don't know. So you're doing 162 divided by 144. 162 divided by 121. You're just going up that list. 162 divided by 100. 162 divided by 81.
81.
Goes in twice.
81 goes into it twice. So this is the same thing as the square root of 81 times 2. Okay, now this is not new, but it's never y'all's favorite thing. 81's a perfect square.
It's not.
So we get to bring that 9, the square root of 81, we get to bring it out to play in the wiffle ball game. So we bring out a 9 because that's the square root of 81. 2 is not a perfect square. So it has to stay in the house and do chores.
That's it.
Yep.
That's not too bad.
Huh.
Was it like
Yeah, it was good. Just Paul. Paul, quit flicking stuff over here, bro. Oh my gosh, look.
Okay, I got one more thing I need to show you. Because you'll see this come up from time to time. Okay. Now that says 11 over 9 minus the square root of 6, and we're told to simplify. That's what we're looking at there. Now let me tell you this first off. We've done this before, what I'm fixing to do, except it had an imaginary number, it had an I. Now we've got a square root. So if I'm looking for the properties that we copied down or something that I can do to this, as it is, there's nothing you can do. Okay, there's no exponents to add or subtract or anything like that. I can't multiply because I only have the one square root, so I can't do anything. But there's a math rule, There's a math rule that tells me I can't leave a radical in the denominator. Just like when we did imaginary numbers a long time ago, we can't leave an imaginary number in the denominator. You can't leave a radical in the denominator.
Would the answer be a decimal?
No. No. It's going to still have a square root in it, which is a decimal, but we got to give the exact square root. So, to cancel out a radical in the bottom, there's a big funny math word that starts with a C. It's called the conjugate. All the conjugate means is that you change the sign. Okay, so look right here. What we have is a 9 minus the square root of 6. So if I want to cancel that out, I multiply it by its conjugate. I change it to a 9 plus the square root of 6. Whatever you do on bottom, you have to do on top. You own it. Okay, so let's do the top first. This becomes a distributive property problem. 11 times 9, 99. And 11 times the square root of 6 is just 11 square root of 6. Okay, now on the bottom, remember the math rule is I can't leave a radical on bottom. So what we're expecting to happen is that those square root of 6s are going to cancel themselves out. So that's 2 binomials on the bottom. So I'm going to do my FOIL. So here we go. 9 times 9 is 81. I'm going to write it over here because I'll put my final answer in a minute. And then a 9 and a square root of 6 just makes a 9 square root of 6. Right here I got a negative square root of 6 and a 9, so that'll make a minus 1. And then on my last, what's the square root of 6 times the square root of 6? Okay, I'm going to write this, Lady Joe, for everybody else, but you're right. Square root of 6 times the square root of 6 will be the square root of 36. Now, I told you the square roots were going to cancel out. Do you see that happening? Right here, you've got a positive 1 and a negative 1. He gone. On the back side, square root of 36 is 6. What's 81 minus 6?
75.
So over here for my denominator on my final answer, 75. Now, Garrett said my answer was going to be a decimal. Yeah, that's a decimal, isn't it? But if Garrett gives me a decimal on that, he's rounded somewhere. If the choice is on the ACT or a decimal, go ahead and type it in. But you got to know how to give the exact answer like we just did. There's usually not very many of those, but when, like Chloe said, we're going to make 100, we got to get that one right. All right, last one of the day. We ready?
Yeah.
Woo! I told you there were variables, so let's throw some variables.
This is being honest.
No, hold back, Emma. Okay, so this will be the challenge problem of the day. Bella's just like putting the pencil down. This will be the big finale that we say for the encore. This is it. Now, if these had these indexes, index C, index I don't know what the plural is. If they had been the same, I could just subtract them. I could say like 7 of these minus 2 of these gets me 5 of these. But that's not the same. So I can't subtract that. So I got to see if I can rewrite this stuff in any way. Power over root, power over root, power over root. So I've got 7, let's get with it here, times b to the power over root times n to the power over root. Okay, all I did was rewrote that using yesterday's stuff, power over root. Now, on my b, what's good? Thank you, Chloe. She's taking over. On my b, 5 over 5 is 1, right? So I just got 7b with an n to the 1/5. Okay? So, say that again. So for now, on this left side, that's on pause. I'm done for now. So let's jump over to the right side and see if we can do anything with that.
So 2 over 10.
Well, simmer down, Hot Rod. 2b is not in the radical, so it's going to stay outside. My n gets its power over its root. Now, Chloe, what's 2 over 10 the same as?
1/5.
Holy cow. So are you seeing that? You got a b and a b. You got an n to the 1/5 and an n to the 1/5.
They cancel out.
So we just created like terms. So minus 2b n to the 1/5.
So would it be 5?
Yes. Now you've got your like terms. So 7 of these ugly things, since all the letters are the same, minus 2 of those ugly things, like Garrett said, gets you 5 of those ugly things. Huh?
Well, she does have a point. Why would y'all just cancel them out?
When you add and subtract, the exponents stay the same. Only when you multiply and divide do you do anything with them.
So you never cancel them out?
Yeah, that's it. That's it. Now, what if I'm looking and that's not a choice? Okay, I like it. Turn that in and that's fine. But check this out. This will be the same as... Isn't that the same?
Yeah.
Yes.
Because the 5th root of n, power over root. So those are the same, if anybody wanted to write it that way. Okay? So here's my summary. If I don't choke trying to tell you. Here's my summary of all of this today. Those properties, as you wrote down your examples, and we worked through those easy schmeezy ones where we kept getting the whole numbers like Maddie said, pretty easy to use. But you're going to have stuff thrown at you like this, where you got to hook it all up and hook it all together, and you get ugly answers. Okay? But you can do it.
Yeah.
Yeah. All right. Tomorrow, graphs of these things. Woohoo!
I'm gonna be smart tomorrow.
I don't like math.